I have a theory, okay? This is like on the level of 0.5 instead of 2. You don't divide it by 2, you divide it by 0.5. Okay? It's on that level. Okay? The expansion of the universe might not be real. I think about this, okay? The universe is contracting. I'm trying to think of how to say this right. I have a theory on a static universe. I'm trying to think. Pause it. Okay. I don't know, we'll start with like the fucking, I'm sorry. The experiments. This is what we want in an experiment. When you look out into the farthest reaches of space, like 14 billion, let's go, 11, inflation, okay, inflation. But you say inflation, because when you look out there, the farthest you can see, the stars are not like warped together. There's no connection as far as you can see. Yes. Dark matter and dark energy. We know that space has mass. Like the Higgs proved that. Dark matter and dark energy. The density of space contracting into like a web. Okay? The mass of space. When you look out, I'm just kind of throw out an example out there. When you look at dark matter, we need telescopes that can see dark matter. We might already have it. 5 billion light years away. 5 billion should be sufficient to measure the variation between the contraction here, because like the space would be fucking pulling into like a web. I think I said that right. I don't know. I don't think I did. I understand completely. I just hard time saying it for the video, but I can say it again. I was just running through it like saying it, fucking shitting me, avoiding the video. I love you. If you can see differences between the dark matter in galaxies 5 billion light years away, and we do. The dark matter, they're wider. Yes, man. Love you. Love you. Dark matter and dark energy. Love you. The contraction itself would not change the position of the web itself. I know, man. As you look back in time, like 5 billion light years away, we need to fucking compare that to where we're at in like a block, like let's say 500 million light years, 500 million light years of space, of a cubic space of 500 million light years of space. It's the experiment. We need to measure the density here and there, of the correlation between dark matter and dark energy, between a block where we're at and a block like 5. I don't. Maybe we can do like 7 billion light years away. Compare the blocks. The cubes. I love you. The space has mass. Now I'm not talking about love you. Like taking it away. I'm talking about the expansion of actual space from inside a static universe. Like the space would expand and it would clump over here. Expand, clump, expand, clump. As the space itself would expand in like a node. It would push and contract the web from dark energy into dark matter as the space becomes tighter and more condensed, like the actual density of this. And this is where it gets like fucking tricky. Time relativity. Time relativity requires mass. Time relativity, mass is intricately connected to time. So the density here and the expansion and the like looseness of the Higgs boson in where there will be dark, like between in the void of space between and like emptiness of you. As this contracts and this density, like where you're at, I love you. It would create like a relative. I love you. A relative. What do you call it? A relative. Distancing. I love you. Yes. Because think about it. Like node. Like rapid node. Rapid here. Yes. And extreme, like it can't get to the other side. The time itself cannot get from one side of space of like a matter of space. You gotta think of a matter of space. Time cannot get from one end of the matter of space to the next side of the matter of space. From one end of the matter of space to the next end of that matter of space, as it where we say dark energy. In the between galaxies where there, yes. Yes. Amen. I love you. I got. Thank you. Think of more experiments. I got the cube comparison here and farther away. The cube comparison here is just basically like the same as we would think of it, but compare a cube of like how many 100 million, 500 million light years. Yeah, I know 500 million light years. Yes, and compare the differential between time, the dark, just the dark matter and the dark energy. The differential between the dark matter and the dark energy. That's one. Between the differential between dark matter and dark energy in this cube, and then the cube 7 billion light years away, and then compare it relatively back, and it will if it creates a pattern. Yes, man. The pattern should be sufficient. That's the experiment I'm proposing. I love you. When we come to technology that can, I love you. Oh my God, I love you. I don't know. I don't know what technology could do with comparing like. I love you. Like you say, the matter, the particles of space, the particles of space. But it's I perceive a particle of space to be a bubble. I love you. One atom can fit inside of one particle. Yes, I know.